Hi guys, hope you're doing well. I'm going to present the sort of structure how we're going to be doing this in this particular discussion because it's going to be fairly short. What I'm going to do is record a video for each one of these questions so that I can explain those terms, so that I can tell you where they came, which lecture and slides they were on, um, and then I can show you my thought process to get from the question that was asked to the answer that I provided. Because not everybody is able to go from that answer that I provide back to how did I get to it. So that's what I'm trying to do here, is show you how I got to it. So what I'm going to do is go ahead and share my screen. And we're looking at the exam practice sheet. Okay, so I'm going to be doing the definition in step 1 for this. So that's what we're going to be talking about. The first one, 1A, is standard pressure. Now my standard pressure is 1 atmosphere. That is defined for you in lecture 12, slide 4. So it's 1 atm. Now it didn't ask about standard temperature, but I'm going to go ahead and do it here anyway. That's in lecture 12, slide 6. Standard temperature is 273 Kelvin or 0 degrees C. All right, that's how we define it. The next one we talk about is 1B, which is critical temperature. The critical temperature is the temperature at which, above that temperature, I cannot have a liquid anymore. So it's the highest temperature where I can still have a liquid or a gas. I can tell the difference. Anything above that, I can't tell a difference between a liquid and gas. All right, so they're all the same. That is in lecture 13, slide 16. Now, the other thing that happens at that point is that last point where the critical temperature is, where I can still see the liquid, at that point there is a minimum pressure that I can apply to turn that material into that liquid. And that's the pressure that we're defining as critical pressure. Okay. Again, that's lecture 13, slide 16. The next term we have, 1D, is supersaturated. So supersaturated. Saturated solution means I have as much material in that solution as can possibly happen at that temperature. Okay, so that's the definition of saturated. Supersaturated implies that we have more than we're supposed to have. Typically, what has to happen for this, depending on which material you're talking about, you either have to raise the temperature and dissolve more solid into the solution, or for some things, you have to lower the temperature and dissolve more in that solution. We then have to allow the temperature to change on that material without disturbing it. Because if we disturb it, then everything's going to fall out of that solution. It's going to go back from super saturated, having too much, to just being saturated. Okay, now that's lecture 14, slide 6. That, we talk about that rock candy is made that way, but that's what we're talking about for that thing. It has more solid in it than it should have at that temperature. Okay. Now 1E says hypertonic. And here's the deal. I didn't manage to get that onto the slides that I presented to you this time. So the ones I used last term had that defined on it. The ones you have this term do not. So E, F, and G, all three of them, do not appear on your slides. Therefore, you are not responsible for them. So I can define them if you're curious, but I'm not going to do it here. You are not responsible for those. Now, having said that you're not responsible for those, I did verify that the test does not contain any questions which ask about those terms. Okay, so that takes us through question 1. I hope you guys found that useful. What I'm going to do moving forward, each question will have its own video. So if you need, if you want a specific answer, you can go directly to it. But I will also put together a playlist for you guys so that you can watch all of them back to back if you choose to. Okay? All right. Well, thank you very much. I will go ahead and stop sharing my screen. And then I'm going to stop my recording. I'll talk to you soon.